So, what's really going on inside a computer's mind when it's playing a game like chess? It's not just about crunching numbers, It's this incredible story of brute force calculation, absolutely brilliant shortcuts, and a journey that kind of redefines what it even means for a machine to think. Let's get into it. This whole thing has been unfolding for decades now, with machines just conquering one game after another. And every time they do, we're forced to redraw the boundaries of what we thought was possible for artificial intelligence. This slide just nails the progression, right? We've watched AI go from being a total brick, barely able to make a legal move, to reaching human-level skill, then blowing past the experts. And for some games like checkers, they've hit the ultimate goal. They've completely solved it. They can play a perfect game every single time, forever. And this timeline, wow. You can just see the acceleration. You have Chinook taking the checkers crown in '94, then the match that shook the world, Deep Blue beating Garry Kasparov in '97. But then, in 2016, a real shockwave. AlphaGo beat one of the greatest Go players on the planet, a game we all thought was protected by this kind of fortress of human intuition. So that brings up the big question, right? How can a machine actually think strategically? Well, it's not about feeling or intuition, it's about pure, unadulterated computation. And it all starts with creating a map of the entire game. Alright, so how does an AI even begin to build this blueprint? Well, to play a game, it first has to understand the entire battlefield. And that means mapping out every single possibility. So the games we're talking about here, experts have a name for them: adversarial zero-sum games. It's just a fancy way of saying it's pure competition. Think of it like a tug of war. My gain is your loss. Your gain is my loss. There's no cooperation, just a straight-up battle of wits. So how does an AI actually see this battlefield? It builds this massive, massive thing called a game tree. Just picture it. The current board is the trunk of the tree. Every possible move you could make is a big branch, and every possible counter move your opponent can make is a smaller branch coming off of that one, and so on, creating this sprawling map of every possible future. And here's the absolute key. If an AI could actually explore this entire map, all the way down to every single little leaf that represents a win, a loss, or a draw, it could play perfectly. It would know with 100% certainty the absolute best move to make in any situation. Okay, so you have this unbelievably enormous map. How in the world do you navigate it? Well, the first, most fundamental strategy is a really elegant algorithm called Minimax. The logic here is actually pretty simple once you get it. You've got two players. Max, that's the AI, and it's always trying to maximize its score. And then there's Min, that's you, the opponent, trying to minimize the AI's score. The AI is basically a digital pessimist. It always assumes you're going to make the absolute best, most crushing counter move possible. So what it does is it literally plays the entire game out in its memory. It looks at every possible final outcome, gives each one a score, like +1 for a win, -1 for a loss, and then it works its way backward up the tree. At every single step, it asks itself, okay, assuming my opponent chooses the path that is worst for me, what's the best move I can make right now to guarantee the best possible outcome for myself? Now, that sounds incredible, right? A guaranteed optimal move every single time. It's the holy grail of strategy. But this absolute perfection comes at an absolutely impossible cost. Look at this number, 10 to the power of 120. That's a 1 with 120 zeros after it. Our brains can't even comprehend a number that big. To put it in perspective, that number is bigger than the number of atoms in the entire observable universe. So yeah, exploring that entire game tree for chess isn't just hard, it's physically impossible. A computer using this perfect, pure Minimax strategy would take billions of years just to make one move. So the perfect player is also the slowest player imaginable. Okay, so this is where things get really, really clever. This is the genius part of game playing AI. If you can't explore the whole map, maybe you don't have to. Maybe there's a shortcut. Think about it. It's a simple but profound question. Do you really need to waste processing power analyzing a move that you can tell right away is just awful? This slide just lays it out perfectly. Let's say you're the AI and you're looking at two different paths. Down path A, you find a move that lets you capture the opponent's queen. Awesome, that's a great outcome. Then you start looking at path B, and the very first move results in you losing your own queen. I mean, come on. At that point, why would you spend even one more nanosecond exploring the rest of path B? You already know path A is way better. You can just stop. And this genius little shortcut has a name: alpha beta pruning. It lets the AI get the exact same perfect answer that Minimax would, but it does it exponentially faster by intelligently ignoring or pruning these massive sections of the game tree that it already knows are losers. And the impact is just staggering. With good move ordering, pruning can effectively double the depth an AI can search in the same amount of time. It can see twice as far into the future. But, and this is a huge but, even this incredible speedup isn't enough to solve a monster of a game like chess. So, that leaves us to the final piece of the puzzle. If even this brilliant shortcut can't get to the end of the game, how on earth do AIs like Deep Blue actually win? This is where it all comes together. Well, the reality is, they kinda cheat. They don't search all the way to the end of the game, because that's impossible. Instead, they search as far ahead as they possibly can in the time they're given, maybe 8, 10, 12 moves into the future, and then they just stop. And at that point, they look at the board and make a highly educated guess about who's winning. They make this guess using something called an evaluation function. You can think of it like a programmed version of a grandmaster's gut feeling. It's a complex checklist that takes a snapshot of the current board and just spits out a score. Positive number if the AI is winning, negative if the human is. And what's on this checklist? Well, for chess, it's a whole weighted list of things. You've got the obvious stuff, like material advantage, who has more valuable pieces on the board, but it also includes much more subtle concepts, like who has better control of the center of the board, the strength of your pawn structure, and of course, how safe your king is. It's a really sophisticated scoring system for a game that isn't even finished. So when you boil it all down, the AI isn't playing a perfect game of chess. It's not some kind of strategic god that has solved it from start to finish. It's an unbelievably fast calculator. It explores millions of possible futures, cuts off its search, and then uses this finely tuned evaluation function to make a highly educated guess. A guess that, statistically, just happens to be better than even the most brilliant human intuition. And that leaves us with a pretty fascinating question to think about. If winning is just about making better, faster guesses, what does that really say about our own thinking?